Hi, everybody, and welcome to OK Zoomer, Zoom chats with creative engineers and more. I'm Aaron Lichtig, Xometry guy and former Jeopardy champion, and as always, I'll be your host today. Today, we are excited to be joined by Joris Peels. And Joris is a consultant who has worked in the 3D printing industry for over 12 years. He's also currently the editor-in-chief and a chief writer as well at 3dprint.com. And you can follow him on Twitter at PILZ or PILZ for those of you in Western Europe. So Joris, welcome. We're excited to have you here today.
Thank you. Thanks so much for having me, man.
Excellent. So what got you into 3D printing to begin with?
Well, actually, it's kind of like when I was a kid, we used to live in Holland. And then when I was like 5 or something, we moved to the UK. In the UK, people had lots more stuff than we were used to in Holland, lots more toys, and there was lots more candy and all this. And my best friend's dad was our garbage man, actually. And he would come every so often to take our trash away. And then at one point, then we moved afterwards, subsequently we moved to Kenya. And all of a sudden, there was very few toys, and there was actual poverty. And I was like actually quite shocked by that, even though I was very young. I was like 9 or something. And there was no candy in the supermarket. And we didn't have a trash man that we came to. It was like there was a big difference between us and the people that did jobs like that, right? Which was also new, which is really weird, right? And we burned our trash at the bottom of our yard. So the gardener would burn all the trash, including light bulbs that would go pop, and including like batteries and stuff. And I remember as a small kid just being like really weirded out by this whole change. And then what happened, we went to a friend of ours' house, or our maid's house, and she had taken our old KLM calendar, right? It's one of those calendars like summer in Kyoto and that kind of thing, you know, those airline calendars. I don't know if you have them, but
yeah.
And she'd hang that up in her house as like our main decorative item. And this like really kind of like, I didn't get it. I was like, wait a minute, that's the calendar from like last year. So why would you have that? Because the calendar is to see what day it is, like today. Right. So then as a really small kid, I started to think about this idea of people reusing things. And wouldn't it be wonderful if we don't have to burn our trash, because there was no trash pickups, right? Just like, and we could just turn that trash like magically, like it transforms into smoke in our yard, right? Like we could turn it into new stuff. And like, just like our maid did our old calendar and does it, and then we could just do that with everything, right? We could take all the things and then make it a new stuff. And that was just like a thought experiment. As a child, I would think about that, and then that was just like this whole idea of taking everything, and then when you're done with it, when you don't need it anymore, turning it into a new thing, right? And making it exactly as you want it. And I thought it was just like a funny kid thing, like, I don't know. And then all of a sudden, it was years later, in 2004 or something, 2003, 2004, somewhere around there, I just happened upon a paper written by Evan Malone and Hod Lipson on this 3D printed robot. So they were doing in 2004, they had this Fab at Home project kind of thing getting started at that time, and which is basically a syringe-based desktop 3D printer, syringe-based open source desktop 3D printer. And they were printing an actuator for this really small fish robot, right? They were printing the batteries out of this on this printer. They were printing the moving parts. And I just happened upon the paper. I don't even remember how I got there. And then I remember just like looking at that and being like, and then it kind of ticked over. It ticked over in my mind. It kept just coming back. And this whole idea was like, and all of a sudden I'm like, it was weeks later. And I was like, this is actually real. Like we can actually do this, right? We actually have a technology that exists, right? And it was called like rapid manufacturing or what was it called? Like freeform fabrication. All these people had all these different names for it. So it was really difficult to find research on it. And I was like, this is real. My kid dream that I thought would never actually work can work. We can take all the stuff we make and we grind it up, and then we could, because I then read about regrind, and I read about industrial recycling of polymers and stuff. So I was like just thinking of like, this is possible. This is actually a thing. We could actually do this, right? And now the printers then were like either really expensive or really like not available. I think it would take a while for that to happen. But at that time already, like you had some of the models like the Fab at Home model where I was like, this is real. We can take all the trash, grind it up, and then make new stuff. And then I got completely obsessed with that. And it took me like, there was no jobs in 3D printing really. There was only like a few companies in the Netherlands that were doing it. And then finally, it was like 4 years later, and I'd read every paper I could find, every publication, everything, which was really easy back then because there wasn't a lot going on compared to now. And I was completely obsessed. And then I got a chance to interview at Philips for what later would become Shapeways. And I got hired as Shapeways' first employee because I was probably like one of very few people in the country that was like super obsessed with 3D printing. And Shapeways got started because it was like somebody had written like an idea to the Philips management people saying like, do something with rapid prototyping and Second Life, right? So, and it was so Peter, the CEO or the former CEO of Shapeways who founded it, had this time kind of morphed away from the Second Life, thank goodness, and he kind of wanted to start this thing, and I was like their first employee, so that's why I ended up getting involved in the market. So, and I've been obsessed ever since. So for now, it's like been like 12 years, something like 13 years, I think. And I'm still like super obsessed. It's like, this is all I do. This is like the main focus of like my entire existence. So, and I'm still, yeah, I still believe in it. I still believe we can make this happen. This idea of this future where we can take everything we don't want anymore and make exactly what we need. You know, and I think it's a very exciting idea still.
That's awesome. What a story. And everyone should read Joris's posts on Quora about the early days of Shapeways and some of the things that they did. I've learned an awful lot from those. Now, shifting from your past to the future, what are the trends you see playing out over the next 3 to 5 years in the additive manufacturing arena?
So generally, I mean, I think if we're seeing a 3 to 5 years time frame, then we're looking at more end-use parts, more direct part production, and more parts at scale. Larger parts, more industrial companies using the technology, and just generally, I think more also focus on printed electronics, nano printing, and microfluidics. Those kind of platforms will start to emerge more, and also soft robotics. But that's kind of like, that would be you know, more stuff that's going to be commercialized. I'm very, very bullish on soft robotics and nano printing and the effects they can have, like making micro machines that can capture one single blood cell, for example, or making machines that origami fold inside your body and then can unfold to propel themselves through your body. That kind of stuff is really exciting. Soft robotics, I think, is very exciting as well, as an area that it doesn't have very many applications at the moment. The idea of making a robot that, you know, through chemical reactions is kind of more of a soft, made out of TPU kind of creature that, you know, sunlight will start a chemical reaction, it'll start rolling in your house, whatever. All right, the soft robotic version of the Roomba would be kind of a bladder-looking thing that, if the sunlight warmed it, it would become oblong. It would have a chemical reaction and would start rolling and collect all the dust. Right, that's a kind of soft robotics way of solving that problem. So far, soft robotics have been really exciting, but still not a lot of applications. And I hope they find application. The same thing with nano printing is really exciting because you can change the way things in the, like our world, behave through making them in a smaller scale. You could have fabrics that, you know, could work as a t-shirt, but that could also work as a heat or cold thing, make things, make you wick heat better, or make every single thing like in one direction more abrasive and that kind of thing. You could do really exciting things with nanotech. And the same thing with printed electronics. I think it's a question now, of course, if we're going to see IoT emerge, if that's actually going to be a thing, is that's going to happen. And for 3D printed electronics, I really mean that at that kind of scale, that I really want us to be able to commercialize that technology. Because I think that's, if IoT is going to make every lamppost smart, then I think to make that custom electronics package with a battery or cell or whatever that fits on that particular lamppost well in a very cheap way is a really great application for 3D printed nano electronic or just regular 3D printed electronics. So I think those are things I think are going to emerge from the research field into more commercialized applications in the next 5 years. If we're looking at things that are going to be bigger now, I think parts are going to get bigger. Right, when I used to work at Materialize, we used to have like the golf ball rule. Right, so if you're thinking about a new application of 3D printing, does it fit in a golf ball? Right, then it'll work. Later on, that kind of morphed, and I think now we're looking at kind of the volleyball rule. Right, now things like post-process technologies and dimension, they're tackling the real issue with the high labor costs associated with 3D printed parts, depowdering, finishing, coloring, that kind of thing. And more development there, we'll see bigger parts. So more parts that can be commercialized cost effectively with 3D printing. So we're looking then at a volleyball size universe, right? So we're looking at much more things that could really be made cost effectively. And then we're going to move away. Like right now, like the stuff that works in the millions, right? We're talking about tens of millions of dental parts in metal. We're talking about tens of millions of polymer parts and dental parts as well for intermediates and end-use parts. Tens of millions of hearing aids, tens of millions of intermediates for lost wax casting for jewelry, and then it kind of ends, right? Then we're already moving down to hundreds of thousands of parts. So we don't have that many huge success stories. And I would like, and if we look at all those things, they tend to be high value things that fit the human body in a particular way, that operate in a regulated type, very tightly controlled, non-competitive type industries. And then we only have like one really good example, which is Invisalign, where somebody's made these thermoforming inserts, and they've really created a new market, right? So apart from that, we tend to conquer certain markets, but we do that in a way that isn't necessarily doesn't lead to millions of parts. And I want us to see us do more millions of parts. I think that'll be possible with new post-processing technologies, things like quad laser metal, things like additive industries, where we're seeing larger machines that are made for production. Metal printers like Velo, which is also would be higher yield systems as well. So I think larger parts and more industrializations. I hope we're able to make that possible. Not just saying, okay, we can do a hip implant that used to be $2,000 and now we can do it for $300, right? But even in that $300 range for like a whatever, like a softball size thing or smaller than softball size thing, I would hope to see more commercializations at scale. So real things at scale. What I expect to happen as well is more industrial companies using the technology. We're already seeing it seep in automotive, of course, and aerospace. After one of the hugest applications, of course, military aviation, and then UAVs, drone type production, where they moved directly from the prototype to production because these things are relatively low volume. But we see that success not really replicated as much as we'd like to in the broader market. So I would expect more high mix, low volume type companies to see adopting that technology. I see them doing it if they're machine builders. I see a lot of machine builders making parts, spare parts for like machines like, I don't know, tire machines or like really expensive, like really low volume type equipment, or like, they only sell 10 of them a year or something, or they only sell 100 machines a year, and they make these really specialized kind of typical, like the German company, like a family-owned company that makes like a tire-making machine or something. They sell 10 a year, but then they have like, the leaders of the world, and they're trying to outcompete China. China's catching up, and they're using this higher variability, lower volume parts so they can test quickly, make in a lower cost overall, and they can make more niche products, right? They're using this to customize one version of the machine to another one that can address a new market, right? Or they're making a higher volume machine, like by introducing a new part, right? They're out competing using this technology, and we see a lot of people like Stryker has adopted 3D printing as a production technology for orthopedics because I think it's strategic. Other companies have said, oh, I'm in orthopedics, I see all the approvals coming, but I'm not going to do the production, right? And we see very few people like really gain long-term strategic advantage in adopting this technology. Apart from certain industries, and then we conquer the industry. So I definitely expect us to conquer like space, right? Because there's so much space stuff going on. We're getting, NASA has proven time and time again, and stuff that's public, that the parts are equal to or exceed the capabilities of forged and cast parts. We can reduce the part cost by 50%. We could reduce development time sometimes as much as 50% as well. So a lot of the commercial space industry has adopted, especially metal printing, but also to a certain extent polymer, and is using it to make better rockets, specifically rocket engines, but also the satellite guys, especially also on the defense front. They've adopted a lot of 3D printing as well. So we're really becoming, for that industry, we're really becoming the way they do business. So this is an industry that's relatively new. The commercial space industry is very new, even though we're doing space for a while. And these guys are adopting, all of them are working on it. And we can see a capability mix emerge from that. And also they're making more demands of the machine manufacturers. They're really buying a lot of machines as well compared to other people. And they're using these many prototypes, iterative improvements. I believe they're going to be moving towards like internal topology optimization, right? Looking at, hey, can we put a golf ball surface on this thing to make the the rocket fuel combust at a lower temperature to make it go faster, that kind of thing. And also like looking more at like, part consolidation, going from 80 parts to 3 parts. And I hope that this kind of like this rocket industry thing and the orthopedics industry will have kind of a halo effect for us in the sense that, if we can make a rocket with it, then what is the guy on the shop floor saying who's blocking the adoption of us as a jig or a fixture, right?
Yeah.
If people can like actually send these multi-million-dollar things to Mars, then you have very little, like it overcomes institutional resistance, which I've had that a lot. And then you have the guys that actually have to adopt this technology in a manufacturing scenario, they hate it. Or they hate it because it's new, because they don't understand it, because it's going to screw with their lives. And it is difficult to control this technology, to make it into a monolithic kind of like a process that works in a kind of Six Sigma type environment, right? It is difficult, right? These guys are coming up with institutional resistance. But if Stryker is implanting tens of thousands of these things in people's hips, right, which has been going on already for 10 or more years, or I don't know exactly how long. So these guys, and other people are making rockets and satellites out of it, So what is there to stop me from adopting this if I'm in like a manufacturing environment, right? So I expect more of that to happen, especially also if you look closely at the process. What you're going to be doing is you're going to be reducing these 80 parts that each have their own like constituent parts, that each have production processes and may need resins or glues and other particular manufacturing steps. You're consolidating into 3 parts that all have the same material and the same production process. And maybe even you don't need fasteners, or you need a lot less fasteners and type of material. And what you can see is that you're really consolidating this, that you're actually consolidating your risk as well. You're not just consolidating these 80 parts into 3. You're concentrating your manufacturing risk on this 3D printing operation, which makes us of critical importance. We're not just a production process. We are a production process for a rather big assembly in your entire workflow, in your entire end use part. We make the whole combustion chamber plus everything around it, and that used to be all these different parts. So now the new design for a combustion chamber actually encompasses many dozens of parts that were previously discrete parts. So it makes the whole production manufacturing process much more fluid, and I hope that would lead people to say, okay, wait, we can do design for disassembly, design for repair. Right? We can stop looking at this part as how do we click it together like Lego, and we can start looking at this like, hey, how are we going to get this lamp out of this car, or how are we going to disassemble this thing so it saves our elevator repairman time. And these are the type of advanced things that, internal topology optimization, nearly no one's doing it, and it's so exciting. The whole idea of saying like not everything on the inside of everything has to be smooth. Right, we can make stuff a golf ball pattern. We can put little Christmas trees on things, and then your tube can be a heat sink, right? We can do crazy stuff like that, but no one's thinking like that yet. So I hope that a new generation of designers, inspired by the orthopedics guys for the safety element and the rocket guys for the exciting element, and thinking if we can organize, if we can work in those environments, then I can introduce this as well as my comparatively less critical application. And I really hope that that's going to be a reason why people can use our technology to outcompete, which I'm not really seeing at the moment. I mean, I'm seeing people adopt it because it's cool, or because they want to be innovative, or because they see other people adopting it. But there's very few examples like Invisalign where people are just like using this as a core business process. So if we look at like my favorite example here is Aidro, AIDRO, which is an Italian family-owned hydraulics company that make hydraulics and manifolds and things like that. And they have figured out that by using 3D printing, right, they can take this comparatively boring thing and reduce the mass of it and reduce the weight to such an extent that the size of the object is smaller. It can be put into more assemblies and more different kind of applications. They can make customized shorter runs. They can make more customized manifolds or hydraulic components for more different industries. And they can use this to really outcompete and stay ahead of people commoditizing their business. And of course, like the really cool thing about hydraulics is if you optimize the internal flow, then at the same time, then you're also going to be able to reap benefits there on like just on the hydraulic itself. So you can make it lighter, you can make it smaller, and you can also make it like more efficient. And I think those are the kind of things where, in orthopedics, like everyone's gradually adopted it, or almost everyone. In space, everyone is adopting it. In the hearing aids, or the in-the-ear hearing aids, of course, are the ones that are made with 3D printing. Almost the whole industry has adopted it, or they've gone bankrupt because they've been. But here, what I really want us to have as an industry, and I hope this is going to happen, is companies like Hydro, which show that one company can outcompete the entire industry by adopting our technology, right? So the hearing aid guys, they all used it. They didn't tell anyone, right? And this is like, I want like a company like Hydro telling everyone, look at this. This is what we made. This is what we did. And we are staying ahead of the curve with this technology. And I think, and what I also hope is going to happen, like I've always tried to also, as a consultant especially, like try to pitch to finance people. And they don't seem to understand it. They see this as an investment in this new process that they don't get, right? And I would love for the more the financial side of the business to really kind of become accustomed to using our technology, and to think of this as like, wait a minute, I've got all of this capital tied up in spare parts. I've got warehouses full of millions and sometimes billions of dollars of stuff.
Yeah,
and I've got ancillary parts.
Kind of thing all the time, where companies come to us, they have things that they need to really make on demand. They don't want to carry a ton of inventory of it, and their 3D printing is the ideal technology for that kind of thing.
Yeah, and I love that idea. I love this idea that the financial guy will all of a sudden realize that, wait a minute, I can free up all this capital, right? Yeah. My next generation of aircraft or things will not have all this capital tied up into molds and tooling and all this stuff. I'm going to print the part directly on demand, and that's going to be really, very, 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 very exciting.
Yep. For sure. Well, Joris, thank you for all these ideas and examples. Some of these trends we're already seeing playing out in the marketplace: larger parts, more end-use production type parts made using additive processes. But some of them, like things that expand inside your body, aerospace applications, we're really on the cutting edge of where the future is headed as a whole, not just what the future of 3D printing could be. Yeah. Well,
definitely. I think, yeah.
Cool. Well, Joris, thank you so much for joining us today. It was a great conversation, a lot to learn, a lot to think about. We will be back again in a couple of days with the next episode of OK Zoomer. Until then, we'll see you around.